Hello everyone. Today we will look at context models and how they are used in system modeling. Context models are used to illustrate the operational context of a system. They show what lies outside the system boundaries, including the interactions of other systems or actors. Social and organizational concerns may affect the decision of where to position system boundaries. Architectural models show the system and its relationship with other systems. The UML standard that we know doesn't have a specific diagram dedicated to modeling a system context, but the relationships can be shown using other diagrams. But we have C4 modeling approach provides a context diagram, which we will see in this lecture. In this example, we present a context model of a car rental system. Here, you may notice that there are interactions between actors and hardware systems, and also interaction between the systems themselves. So let's investigate a little to understand what this diagram tells us about the car rental system. We have a system boundary called car rental system. This shows that the proposed system uses a web server and a smartphone device. The arrow from smartphone device to web server shows that the smartphone uses or interacts with the web server. Probably smartphone is accessing billing data in the web server. We see an actor called Data Cloud that gets the information from the car, and the same Data Cloud actor is connected to the web server for billing the rented car. Data Cloud also interacts with a car rental application. The customer can see the available cars and their properties that one can order. Another actor, Payment Gateway, is connected to the rental billing system located in the web server and also the car rental application located in the smartphone. It means that there's an external payment gateway system that is used to transfer money from the user account to the company account. The rental billing system provides payment information while the application is used to pay for the services. Car service staff can use a website where one can manage operations using a rental billing system. As you can see, the diagram shows what parts of the system need to be implemented. Also, it shows what external services will be used. System architects can use this information to plan the interaction between systems. Now let's talk about system boundaries. They are established to define what is inside and what is outside the system to be implemented. Look at the previous example and try to find out internal and external systems. They also show other systems that are used or depend on the system being developed. The position of the system boundary has a profound effect on the system requirements. On the other hand, the system requirements may influence the system boundaries. Also, defining a system boundary might be a political judgment. There is no single diagram in UML that could be used to define the context of the system. This doesn't mean that UMLs cannot be used to show context models. It means that UML doesn't have a specific diagram to represent the context models. The UML boundary element is used to provide a context in different diagrams. Use case, deployment, component diagrams could be used to show the context. The example of a car rental system was modeled using a deployment diagram. UML use case diagrams also the system boundaries to show the interaction between internal and external actors. The customer and a banking system are the external actors that interact with the ATM system, performing three operations: withdraw cash, deposit cash, and view balance. This diagram also shows that both actors, a customer and the banking system, need to work together so that all these use cases will be successful. For example, if a banking system is offline, the customer will not be able to withdraw the money. In this slide, you see a C4 modeling approach first level diagram. C4's first level diagram is a system context diagram. It is showing a big picture of the system landscape. This is a diagram one could show for non-technical people. Actors are specified within square brackets, and each actor has description which shows necessary information for that actor, and interactions can be done using arrows from one actor to another. Once you have a good understanding of the structure, you can supplement the C4 landscape diagram to show other aspects. The C4 model provides a static view of a single software system, but in the real world, software systems never live in an isolation. For this reason, and particularly if you are responsible for a collection of software systems, it's often useful to understand how all of these software systems fit together within the bounds of an enterprise. To do this, simply add another diagram that sits on top of the C4 diagrams to show the system landscape from an IT perspective. Like the system context diagram, This diagram can show the organizational boundary, internal, external users, and internal, external systems. Essentially, this is a high-level map of software systems at the enterprise level, with a CFOR drill down for each software system of interest. From a practical perspective, a system landscape diagram is really just a system context diagram without a specific focus on a particular software system. We have overviewed context models and the elements that are used to define the system boundaries. Let's have a look at the key points to take out from this lecture. Context models show the system boundaries. They show other systems that are used or depend on the system being developed. UML doesn't have a specific diagram, but there are several diagrams that can show the frontiers of the system. CFOR's first level diagram is a system context diagram. Thank you for your attention. I hope to see you at the next lecture.